Welcome to the project. We call it as iKrushi. This is an isolated system, which can create any atmosphere inside, without getting affected by the external environment. This prototype will elaborate the complete working of the isolated system, and will also demonstrate the remote monitoring of the farm. The working of the isolated system can be explained through the sensors and actuators. They will be controlled by an Android application. The user, that is, the farmer, will be asked for the sign-in for the authorization purpose. The farmer can select any project for the cultivation of the specific crop. The status regarding the temperature, soil moisture, humidity, and the presence of light will be displayed. If the project is initiated, at the grid it will display the status as normal, low, or high. First, temperature status. The live data logging can also be monitored on temperature status, and it will show the live temperature of the system. Then the soil moisture status. The live data logging can also be monitored on moisture status, and it will show the live moisture status of the system. Similarly is the humidity status. The humidity status also gives the live humidity level in the isolated system. It can be crucial in growing the cotton plants. The light ambience can also be measured. The presence of light is measured in lux values, which can be used so as to make sure that crop are getting enough light for photosynthesis. Also, the actuators can also be controlled through this app. The hydroponic light can be switched on and off. Similarly, the working of other actuators, like water pump and cooling fans, can also be managed. The internal structure of the project is divided into two parts. First is the master board. Master being the Raspberry Pi 3B, which has ARM-v8 architecture-based processor. It has 40 GPIO pins and it operates on 3.3 to 5 volts. Second being the slave board, for which we are using Arduino Uno. It has a Mega controller. It has 20 digital and analog I/O pins and also operates on 3.3 to 5 volts. The soil moisture probe is connected to Arduino through a DC adapter. LDR, which stands for light dependent resistor, is connected to Arduino, which is used to measure the ambient light. Arduino Uno is connected to Raspberry Pi through a wired serial connection. An ultrasonic rangefinder sensor is connected to Raspberry Pi, which is used to find the depth of the water level in the water tank. The DHT11 sensor connected to board, which is used to measure the temperature and humidity of the environment. A relay board is connected to Raspberry Pi 3 for controlling actuators, as Raspberry Pi cannot handle more than 5 volt of input current, or we can say, the flyback current. The relay board is used for controlling actuators, which are fan, pump and the hydroponic light.
Due to many reasons, the condition of food industry is getting worse, leading the world to global famine. Farmer suicide rates has been increased. According to the year 2014-15, the suicide rates has been increased to 42%. According to the sources in Times of India, 226 farmers have committed suicide in the past 3 months.
According to the UN projections, by the year 2050, the global population will rise from 6.8 billion to 9.1 billion, a third mouth more. And also, due to war-torn areas, it might result into food shortage. So we need to take some prior actions so that we may not have to face such kind of situation. and if not taken, according to UN projections, then by the year 2050, nearly 370 billion of people might face starvation.
The major cause affecting food industry is climate change. The global temperatures have been risen up by nearly 2%, which is far more than what scientists expected, which causes complex climatic changes such as El Nino, which typically includes reversing of rain patterns, which causes droughts, which can severely affect food industry.
Due to increase in contamination of groundwater by excessive use of chemicals like C8 used in arsenic and Teflon, results in poor yielding of food quantity as well as its quality.
This prototype cannot be elaborated completely in one go, as we can show working of some sensors, but we cannot show the complete life cycle or the complete growth of the crop in one demonstration.
Resources used. We have used master-slave architecture in our project. For master, we have used Raspberry Pi 3B. For slave, we have used Arduino Uno. We have used number of sensors like DHT11, which is used to measure the temperature and humidity in the environment. We have used LDR, that is light dependent resistor. It is used to measure the presence of light in our environment. We have used ultrasonic rangefinder. It is used to measure the depth of water in the water tank. We have also used soil moisture probe. It is used to measure the content of moisture present in the soil. These sensors are used to collect the data. We have used number of actuators like pump, hydroponic light and fan. These actuators are used to control the environment.
Another integral part of our system is an Android application. This Android application is used for monitoring and controlling the environment. This Android application is backed with the Ubuntu server located in the cloud, which acts like a backbone to maintain the ubiquity of our system.
The major issue we faced was availability of sensors according to different situations, like the pH sensor were only available for industry grade, not for normal use. Another major issue we faced was interfacing sensors with different boards required different libraries.
This prototype, if gets implemented, then any crop can be cultivated in any geographical area. Also, it will increase the food production, as any crop or any plant can be cultivated in any month of the year.
External unfavorable climatic condition will not remain foreign to the plant. And last but not the least, this will make farming a zero loss business and will make our country Krushi Pradhan Desh in true sense.